Good morning to all. I would like to speak on optical fiber communication. In this part, I am taking care on optical fiber nowadays because all living persons nowadays using the optical communication for information transformation. So in this technology, each and every students, technocrats, research faculty and also faculty who is handling the subjects should know the importance of optical fiber communication. In this part, we want to know what is the meaning of optical fiber. Optical fiber is a communication medium in which the information is being propagated in the form of zigzag path. Also, the optical fiber is a dielectric medium in which the signal is propagated without any degradation. Before looking the fiber working performance, we want to see three important classifications. There are three important classifications are, one is called simplex. Simplex is a communication type in which the signal is going to transfer from transmitter side to receiver side in only one direction. That is to be called simplex. Example, TV, television type. Now we are looking always at TV, telecommunication system and also radio communication system. In the radio communication as well as the television system, we are looking only the information only one direction. Whereas we cannot send back to the receiver side what we want to convey. That is one-way communication, example TV or radio. In radio also we need to hear only the information, whereas we cannot send the information back to the transmitter side. This is only possible. The good example TV and radio. The other second example is duplex. So duplex is good example for telecommunication system. Telecommunication. Nowadays we are using telecommunication system across the world. So without fiber optic communication system, the information is never possible to transfer each and every corner of the world. The duplex in the sense, the information is being communicated to everywhere bidirectional path. User can simultaneously receive the information at both ends. Receiver side can be received and the transmitter side can be sent. There are two things are possible at a time. Example, now fiber optic communication system is good example for duplex. The third one is half duplex. Half duplex is the example for walkie-talkie. Walkie-talkie is good example for transmitting information through the communication medium like in the kind of way. In this, the user as well as the remote side both cannot receive the information simultaneously, whereas one can receive the information at a time. The next time, the user can lift their transmitter, then only the other people can hear the news. So this is the principles available in walkie-talkie. Is good example for half duplex communication. Now I come to the optical fiber, how it is used in optical fiber communication system. In general, current communication system used only the single mode optical fiber. Why is single mode fiber used in optical fiber communication? Because the optical fiber communication is a very small, thin medium. The thickness in the order of 8 to 12 micrometer. were like our hair size, through which you imagine how the information is being transmitted to the entire distance without any degradation. So this is the objective of the optical fiber. Even though the thickness is very small, how this kind of very big data, including image, data, voice, everything possible to send across the entire regions of the optical fiber. This is because the attenuation is very low and bandwidth is high. This is the main important thing in optical fiber communication. Because of this reason, the single mode fiber is being used in communication system nowadays. Now we want to see the importance of optical fiber transmission. The principles of optical fiber communication is total internal reflection. Simply we want to say what is called TIR. TIR is the total internal reflection. Total internal reflection. So in this, we are transmitting the information through one regions of the optical fiber, and it is continuously reflected inside the fiber throughout the region. Like this, the signal is degraded and also reflected on each and every point before reaching the final. Then only we are getting the entire regions of the optical fiber. This is the main principle. Now, the angle of incidence of light ray exceeds the critical angle. The one way. The other way, when the light incidence on the dielectric of lower index from dielectrics of higher index. In this, we want to see the fiber core region as well as the cladding region. The third region is said to be called the external jacket is provided. So this is going to provide enforcement to the optical fiber. So this is the classification as well as the classifications of optical fiber. Next we want to see the basic optical link, in which how the information is transmitted through fiber, how it is being processed. We want to see now. Let us see the input section. We are using what is called digital signals. In this, we are using the input signal, and we are received the reproduced signal. The same original signals we are being received at this end. So this process is being carried out in the fiber optics network through various optical connections. Now we want to see the inputs section. We are using transmitter. Transmitter always used optical side fiber, either LED or laser diode. These are the optical source. The source is said to be called an EVO converter. EVO means electrical to optical. Electrical to optical converter. Optical converter. So this is called the EVO converter. The receiving end, we want to say photodiode or APD, avalanche photodiode. The device is said to be called OE converter. OE converter, optical to electrical converter. Optical to electrical converter. So this is the basic principle. If you know the concept of EVO converter and OE converter, within the limit the signal is converted in this one. Now we want to see the signal conditioning the fiber. The light is emitted through the light emitting diode or laser diode. It's a monochromatic light in which the fiber is transmitted, the light is transmitted over fiber. Before launching the optical fiber, we want to make clearly the aligning process. Whereas in the case of electrical wire, you see, once we make a twist, the signal is going without any problem. Whereas in the case of optical fiber, it is not possible. Since we need a technical alignment with a skilled person, we want to connect the optical fiber through splice. What is called a splice? Splice is a permanent connector. Through the splicing technology, we want to make two broken fiber into original through the splicing technology, or the broken two fibers are connected together with the connector type also. Connector. Using the connector technology, we want to see this one. So using this, we have to connect the optical fiber through this one, then it will pass through the optical fiber by using various absorption phenomena. While the signals is being permitted into the optical fiber, we want to see three important things. One is called attenuation. Attenuation is one important phenomenon. Network is said to be called, the other one, the absorption part. Now, we want to see the advantages of optical fiber communication. Optical fibers is used in different applications. It has enormous potential bandwidth. This is the main important applications of optical fibers. It has a numerous and wide bandwidth through which we can send a data, image and audio with various images are being sent at various destinations. The other important property of optical fiber is small size. Like our hair size, the thickness is very small. You can imagine through the small dimension how the enormous amount of the data is being transmitted over the entire length of the fiber. So this is the tremendous of optical fiber communication. And also it has a small weight, so that the revolutions of optical fibers is being used everywhere. Another important property is electrical isolation. In the case during the rainy season, there is no affections of optical fiber, because optical fiber is a dielectric medium in which the electromagnetic waves are propagated in the form of zigzag path. So this is the main reason. Another thing, due to heavy thunder, there is no affections of optical fiber, since the optical fiber is made up of silica. Silica is nothing but silicon dioxide. So this is a dielectric medium like a glass. When the light falls on this one, it will immediately reflect and transmit the signal over the entire length of the optical fiber. Then crosstalk. There is no crosstalk is available. The tapping problem is not available in optical fiber, whereas in the case of others like the electrical cable and other security concerns are possible. But in the case of optical fiber, security concerns 100% highly secured, since there is no tapping of information in any corner of the fibers, not possible. Low transmission loss. While the information is being communicated, there is no signal loss. This is another added advantages of the optical fiber. Ruggedness and flexibility. The optical fiber is useful for sending the information with very flexible manners. And also maintenance problem is very simple in this optical fiber. For example, 1 meter cable length, we can see how to connect, how to receive the information. Everything we have a connectivity through which the information is being received. Potential low cost. The available, even though it is available, abundant in nature, the cost wise this is cheaper, and also we can see the quality of the fiber. So now so far we have seen the applications of optical fiber in the small industry and other application areas. Now we want to see the applications of optical fiber in the broadcast, cable operators, satellite and wireless communication data network. So this is another important applications of optical fiber. Now we look at the structure of optical fiber. In the case of optical fiber, you see the structure. There are three important layers. The first layer is said to be called core. Core is important layer of the optical fiber. The dimension is said to be called N1. N1 is said to be called refractive index. Refractive index of the core. Refractive index of the core. Next one said to be called cladding. So cladding, the another layer is said to be called dimension N2. So this is the refractive index of the cladding, that is said to be called Ri. Ri is nothing but refractive index of the core. Then the N1, the dimension sometimes said to be called N1 by N2. What is called N1 by N2? N1 by N2 is a dimension for representing the fiber dimension. N1 stands for refractive index of the core, N2 stands for refractive index of the cladding. So based on this, the fiber dimension is identified. Now we see the performance of core. What is the meaning of the core? Core generally is said to be called primary. Here, core is only responsible for carrying the light throughout the region. Here you see the structure. The structure is said to be called core. The core is surrounded by what is called cladding. Here, now we want to see here another kinds of application. Here the core is surrounded by is called cladding. This is said to be called cladding. Here the first one is core. Core dimension is represented as the N1, cladding is representing as N2. So this is the structure. Then core N1, the dimension N2, then over which we are providing what is called buffer. The outermost region is said to be called buffer. What is why is buffer is required? Buffer or the term is said to be called jacket. Jacket is going to provide enforcement for the optical fiber, and the same way cladding also going to provide the protection of the core, because core is mainly responsible for carrying the light throughout the region. So this is said to be called core cladding. So this is the structure of optical fiber. Now we want to see the importance of optical fiber with the various levels. Core, the center of the fiber where the light is transmitted, that is said to be called core. The cladding, the outside optical layer of the fiber that traps the light in the core and guides it along the fibers, is said to be called cladding. The buffer coating is said to be called buffer or a jacket. A hard plastic coating is provided over the entire fiber surrounding, which is going to protect the glass from moisture or physical damage. So this is one of the important structures of optical fiber, this one. Now we want to see next one, the types of optical fiber. What are the types of optical fiber? Here the fiber type, single mode fiber SMF, multi-mode fiber MMF. This is further SMF, single mode fiber is again divided into single mode step index fiber, single mode step index fiber, single mode graded index fiber. Single mode graded index fiber. So this is the one of the types. Now what is called a single mode fiber? Nowadays the optical fiber, particularly the single mode fiber, is used in communication because it has lot of privileges, including intermodal dispersion is less and also the core dimension is very small. Example, the single mode fiber dimension of the core is around 8 micrometer, whereas cladding dimension N2 is around 12 micrometer. So this is the main thing. So during the dimension is very small, then the signal is being transmitted, so that the single mode fiber is always used in communication, now current communication system. Communication system nowadays we are using. Next we want to see the importance of the other single mode fiber. Now I explained this one. Here the core dimension is, you see that in case of single mode fiber, the core, this middle region is to be called core. In this core, you see the entire region is the same or uniform cross section. This is the fiber transmitting end, this is the fiber end, receiving end. Then over which the core is to be called the cladding. Cladding is surrounded by other one. This is not available here. It has a smaller core, only about 9 micron, and is used for telephony or cable TV with laser sources at the range of 1300 and also 1550 nanometer. It can go very long distance at very high speed. Now we want to see multimode fiber. What is the meaning of multimode fiber? In the multimode fiber, here you can see it has a bigger core dimension, the 62.5 micron. A micron is one of millionth of a meter, but sometimes called the microns, and is used with LED sources at wavelength the order of 850 and 1300 nanometer for short distance communication purpose. So in this, the multimode fibers, you can see here the modal dispersion. Here one mode is finished, then it continues other one. So like this, the mode is continuously propagated without any interference at the intermediate level. Whereas in the case of single mode optical fiber, the signal is being transmitted over the entire region with the same uniform cross section. Here is the dimension is blocked at various level. You see here the multimode step index fiber. Here multimode step index fiber, the core is abruptly changed with respect to the radial change. This is the main applications of the multimode gradient index fiber. Now we want to see the application window. What is the meaning of application window? The application window is classified into 3 types. Window 1. Window 1. Next window 2. Window 2 represent like this. Window 2. Window 1 covers the wavelength in the order of 800 to 900 nanometer. 800 to 900 nanometer. Here you can see window 2 represent here 900 to 1500 nanometer range. Here you can see 900 nanometer, 1550 nanometer. In fiber optic communication system nowadays used the optical sources for short communication, short wavelength range, short wavelength range, the order of 800 to 900 nanometer. So this is the wavelength used for this short communication system. Next we want to see long wavelength region. Long wavelength range. Long wavelength range we are using 1310 nanometer and 1550 nanometer. 1550 nanometer. Here sometimes it will be called 1.3 micrometer or 1.6 micrometer. So we also know the wording of using wavelength range, whether it is nanometer or micrometer. Anything is possible, depends upon the changing the value of the dimension. So in general we are using 1310 nanometer and 1550 nanometer for long distance communication. Now we want to look at 850 nanometer range. 850 nanometer multimode range is standard for 10 phase optical fiber. This one 1300 nanometer standard 100 base optical fiber Ethernet range. 1320 nanometer for single mode fibers. This is used in the gigabit Ethernet range. It is commonly used for application where greater distance is required than can be achieved with multimode fibers. Next you want to see here 1550 nanometer with single mode. Here Ethernet standard not possible, and also you can see the long distance communications, the particularly telecommunication speed up to 40 gigabits range we are using. Now another important the characteristic of optical fiber, while the signal is being sent through the optical fiber, there are three important characteristics we want to look in optical fiber, or the three important phenomenon is going to degrade the optical fiber. What are the characters? One is called absorption. One is called absorption. Absorption property. The second one is called scattering. Scattering. Third one is called bending. We want to see the three important phenomenon while carrying the light inside the optical fiber. If we reduce all the three properties, then only we got no problem in receiving the quality of signal at the end of the fiber. What is the absorption characteristic? The absorption characteristic is while the signal is being allowed inside the fiber itself absorbs some light along the sides. Now we want to reduce how this kind of absorption takes place during the optical power heat caused by impurities in the optical fiber such as hydroxyl ion. If the hydroxyl ion presents, it will create enormous amount of the loss or attenuation inside the fiber. So we want to eliminate this kind of absorption property. Now we will look at the scattering property. Scattering, how this occurs, the change of directions of optical rays or photons after striking small particles, it may be occurred in this one. This is property shown in the visual form. You can see here a small picture is available in which while sending this one, the absorption immediately takes place. After entering the middle part, then due to the presence of photon impurities in this one, the scattering is occurred. Then after that, you can see the minimized the signal is being received at the end. That is to be called decreased signal. This is shown in this image. The diffusions of light beam caused by inhomogeneity of the transmitting materials. So this is one important thing. Another thing is called bending. Bending, how it will occur while twisting the optical fiber, normally it will occur. If you want to make a normal curvature, it will reduce or degrade the optical signal. So that we want to maintain the optical fiber during the signal propagation. Another thing, what is the problem called attenuation. Attenuation is another important property of this optical fiber. What is called attenuation? Attenuation is the property. How do you define that? The attenuation is always defined as dB. Decimal is inversely proportional to 1 by L. What is called length? L is the length of the optical fiber. Length of the optical fiber. In this case of the length, in the fiber optic length, you can see the attenuation. The attenuation, the decrease in the signal strength along a fiber optic waveguide caused absorption and scattering, and attenuation is actually expressed in dB per kilometer. That is L, while the L increase, then the loss decrease. First you can see dB is inversely proportional to length. If the length L is increased, dB decreased, or alternative, dB increase, the length decrease. So this is the nature of the optical fiber. So using that, we want to eliminate the attenuation inverse, then add alpha. dB is said to be called the term alpha 1 by L, 10 by L, P in by P out. Where P in is said to be called the power is transmitted over the fiber. Power is launched in fiber. P out power is received at the end of the fiber. To see next attenuation. Attenuation is always represented as dB is equal to 10 by L log of P in over P out. So this is the equation for representing the dB loss, attenuation. Attenuation or central is to be called loss. The loss in optical fiber is represented as the dB. That means 10 by L, the log of P in over P in. Whereas P in is nothing but the power is launched. Power is launched in fiber. Whereas P out power is received in the end fiber. That is the ratio of the power. So this range is said to be called ratio of the power, that is represented as the form of what is called P in. P in is the power is launched through optical fiber. That represented a light, quantity of light is going inside fiber and is making a difference in the optical fiber. We want to evaluate the quality of fibers. Then P out taken from, you see here, P out is power is received in the end of the fiber. So totally we want to take the ratio of these two, then only come to know the power quality. Then we see the power transmission, data transmission in the optic fiber is good. This one. Then if the length L, if the length stands for length is increased, that means increased, then what is called a distance decreased. Length is increased, then dB or loss decreased. So this is represented. So this, in this way we easily understand the fiber loss. If the loss dB increase, then length decrease, or length increase, dB decrease. So this is the ratio in between loss and as well as the length of the optical fiber. Now we see carefully the dimension. The dimension of the fiber, if you know, for example 8 by 12 given. Suppose the students in your question they may be asked like this, 8 by 12 what? What is the meaning of this? What is the meaning of? What is the meaning? What is the meaning of this? If anybody asks question like this, you should know the numerator 8 stands for the dimensions of the core. Dimensions of the core. The denominator 12 stands for the cladding dimension. This is the cladding dimension. Cladding dimension. The numerator represents what is called core dimension. Core dimension. Then only we come to know the fiber structure through which, or instead of this you can put what is called this one, 8 by 12. So like this the core dimension is represented always in this one. Now we are in the attenuation state. So definitely we want to see the fiber quality in the sense we look at the attenuation. How we want to reduce optical fiber in the attenuation process. Attenuation is always there. This is generally loss, power loss. In case the electrical power is going everywhere, due to the sudden heat falls on this one, the power loss takes place. So like this, in the optical fiber communication, the loss occurs due to the three important phenomena, namely absorption, scattering, and loss. Another property is called bending. So these are the major this problem nowadays in optical fiber. Sometimes due to inhomogeneity of the optical fiber, the loss takes place. So we want to see carefully the optical attenuation in this one. Next we want to see the other kinds, that is called the fiber dimension. Here you see the other laser. Now we want to carefully see that the attenuation problems and loss problem, fiber characteristic, and the other characteristic like the characteristic of all those things. As I told initially, the optical fiber, the input section is said to be called electrical to optical converter. It is said to be called EO converter, electrical to optical converter. Optical. The transmitter side, this is in the transmitter side, whereas the receiver side, it is to be called OE converter, optical to electrical converter. Optical to electrical. We look at the two important things for converting process. In the case of the transmitter side, we are using always either LED, in this case of LED, or laser diode. There are two things, laser diode or this one. This is said to be called laser diode. This is said to be light emitting diode. Light emitting diode. So light emitting diode characteristic compared to laser, the directionality is less and attenuation is more than laser diode and this one. But this is always used for long distance communication. Long distance communication LED for short distance, in the sense 800 to 900 nanometer range LED power, whereas long diode 1300 nanometer to 1500 nanometer. So these are all ranges is being applied to the optical fiber communication nowadays. Now we want to see that the laser diode concept. So laser diode, you see here the proper alignment given here. Here the optical as well as the laser diode chip is given. You know the principles of optical diode as well as the laser diode. We have three layers section: ground state, middle state and upper state. These are the three states. The level is said to be called E1, energy state, and number of atoms available in the state is said to be called N1. Next to ground state is said to be called metastable state. It is represented as the E2, and number of atoms in the level is said to be called N2, and upper state number of electrons as well as the atoms available is N3, and energy state is represented as the E3. So like this, the energy level is distributed in laser system. According to population inversion, the optical pumping take place. Due to this kind of the optical transmission, the light is being emitted in the form of stimulated. So that is to be called laser light amplification by stimulated emission of radiation. The emitted light is very monochromatic, whereas in the case of light emitting diode is monochromatic, but in the case of spectral width is low as compared to laser diode. Laser diode spectral width in the order of watts, but here in light emitting diode in the order of milliwatts. So this is the major difference between laser diode as well as the LED. So that we are preferring the laser diode is always for communication purpose, particularly for long distance communication. This one aspect. Next I come to the light emitting diode. So light emitting diode is one of the optical sources while used for our laboratory application as well as the short distance communication application in this one. In this part we want to see now the LED configuration. LED structure, even though it is very small, the light depends upon the semiconductor materials. Semiconductor material, the property is classified. This one light emitting diode, you have to look at carefully this point. Here the light is a semiconductor that emits incoherent light. When forwarded bias given, it will emit light. So this is the principles of optical fiber. Here NPN, nowadays we are using the NPN, structure is called NPN. Now we want to see a small example how to connect the optical source with the help of the optical diode. Here you want to see here, this is the barrier junction available, is a B junction, this is N junction. Now we are providing P junction to the positive of the supply, then N junction is giving to the negative of the power supply source. That is to be called power supply, this one. Here this is the term is to be called forward bias. Forward bias. What is forward bias? When the junction of the P terminal is given to the positive of the supply and the N junction of the barrier is given to the negative of the supply. So the structure is said to be called forward bias. When the diode is forward bias, the light is illuminated. So this is the concept of any kinds of what is called a forward biased section in this one. Whereas reverse bias, the concept is reverse. That means the Reverse bias, the potential barrier is high. Here barrier is less. Here barrier is less. Here barrier is high. Barrier is high or wider. Wider. The P junction is given to the negative N region is given to the positive. So that region is said to be called the reverse bias. So in this case of the optical sources is applicable only for emitting light in the form of the forward bias. Good example given here. Now here look at here, laser diode is available, the lens is available to collimate light which falls on the fiber. Here fiber is ready for collecting all the aligned output from the laser diode and it is being collected for some other application. Whereas in the case of the light emitting diode, we have a different structure. Each structure is going to provide the strengthening of all the materials and contact for both the upper side as well as the bottom side. Within the channel, we are getting the light emitting source. This is the pattern for collecting the optical source. The layer is multiply given in the form of P and N layer types for constructing. In this gallium arsenide, GaAs, that is called gallium arsenide and aluminum gallium arsenide. So these are the semiconductor based material used for fabricating laser diode as well as the LED. So these are the important applications of the optical fibers. Another thing, we look at carefully the application in the form of receiver side. So far we had seen the sources in the transmitter side. Now we carefully see the receiver side. Receiver side is to be called optical to electrical. Receiver side, we are using the optical fiber to collect all the optical sources. The receiver is said to be called OE because the optical receiver is always receiving the optical source to electrical, or it is being converted the received optical signal into electrical. That is said to be called the optical to electrical converter, as I said earlier, optical to electrical. Generally, this kind of receiver side we are using photo detector. PD stands for photo detector, or APD, avalanche photodiode, or avalanche photodiode we are using. Avalanche photodiode in this. So similarly, light emitting diode as well as the laser diode, the photodiode also applicable for long distance as well as the short distance, long distance applications. So like this, you want to see that short distance communication we are using this kind of way. Short distance 800 to 900 nanometer. Here long distance 1300 nanometer to 1500 nanometer. Similar way, these devices are going to make a change in the receiver section without any distortion or any loss can be averted in this one. It has a high bandwidth for transmitting this one, low loss, low noise configuration. These kind of devices like receivers are having low noise, then only we can receive the information without any noise. So this is one of the added advantage of this one. Here you want to see photo detector. Here photodetector fiber cladding here, core is given here, fiber core. The inside of the fiber is to be called this one. This is cemented over the optical source, which is being provided the optical signal to the fiber. The fiber is ready for collecting the source from this one. Here generally semiconductors, electron is having hole and electron as well as the electron hole pair, in which the optical signal is being received. Here the optoelectronic transducers such as the pin photodiode or avalanche photodiode are being used here. Here positive intrinsic as well as the negative electron regions are widely used. Next one, photodiode. Photodiode is nothing but semiconductor device that converts light to electrical current. Now we want to see the point-to-point communication system. Point-to-point communication. Point-to-point. Point-to-point transmission. Here you have one transmitter, here it is to be called a transmitter, this is receiver. In between we want to connect the optical fiber. Then you see that this one is called a EOE converter, this is called a EO converter. Here is input signal fed through LED or laser. Here we are collecting the optical signals. The output signal through APD, avalanche photodiode or photodetector, or sometimes it will be called a pin diode. In way the fiber is being communicated one way here, the same way here. That is to be called bidirectional. Bidirectional communication system. Bidirectional communication system. How is it to be called bidirectional? As I told in the very beginning, bidirectional is nothing but anybody can receive the information simultaneously through this one. So like this, the telephone system is working. Telephone or telecommunication. Telecommunication system, this one. Now here you can see the point-to-point communication system. What is the meaning of point-to-point communication system? Point-to-point is nothing but a place. One place is located at the receiving end, the another place is located at the one particular location. In between we have a transmitter as well as a receiver. Here the signal is fed through transmitter side and is being received through the optical fiber. The fiber structure is being provided here. Then we are receiving the signal at the output end without any crosstalk. Then through which we can receive the information over a long distance without any repeaters. Nowadays you can see the roadside repeater is available. The Department of Telecommunication is putting every 2 kilometers the repeater. What is use of repeater? Repeater is an electronic device which is useful for amplifying and reshaping the signal, so that they are putting every 2 kilometers as the repeater. You see, whenever you travel by car or by bus, you can see along the roadside a white marking stone is available, is painting with red and white, marking as OFC. That means the line is carrying optical fiber with the buried manner, which indicating the optical fiber going on throughout the section. That meaning of the optical fiber section. Now next we want to see the coupling mechanism. Coupling mechanism is very important in the communication system side. To do this kind of work, we need a skillful work or skilled person. We need to do this kind of work. How we want to do this kind of the coupling work? Before that, we want to see what is the meaning of the connector, coupling mechanism. Coupling mechanism in the sense, there are two things. One is called splices, other one is called connectors. How they are doing this kind of connecting work, we want to see carefully in this one. The splices is to be called a permanent connection. Splices to be called a permanent connection, whereas connector is to be called a temporary connection. Permanent, whereas connector is to be called the temporary connection. Temporary connection. How we want to do that? But in the case of the electrical connection, we see that once the line is broken, we want to connect it to send the signal over the entire length. How this is possible? Just to make a twist, then you can join, you apply the tape over it, then only the electrical signal is being propagated. Whereas this is not the same case possible in the fiber optic communication system. This is one end of the fiber. So this is the another end of the fiber. This is the original fiber. You can see that. Okay. This is the original fiber given here. Once the fiber is made a break at this point. Break at this point, then you see look like this, the broken. This is the broken fiber. Broken fiber. How we want to join? We want to join. How we want to join this fiber? Joining, we want to see what is called alignment. Alignment. So alignment is very important. We want to connect the fiber with a very precise manner. Very precise manner. We want to join fiber 1, this is the fiber N. So we want to join these two N carefully or without mismatching. We want to join together 90% exactly, then only the fiber signal is being propagated through this. Otherwise, what will happen? The light scattering. Light scattering take place. How to avoid this? How to do that? So that we are going for coupling mechanism. Coupling mechanism, we want to look at that. Coupling process. What is the meaning of coupling process? Now we want to see here a splice. A splice is a permanent connection of two optical fibers through fusion or mechanical means. Here you want to see the fiber. This fiber N, this is the fiber N. In between the fiber N places available for connecting this. So this is a good example for fusion splicing. This is the broken end. This is the broken end of the optical fiber one region. So this is the another regions available. So how we want to connect it? How we want to connect? This is one end, this is the another end. In between, how you want to connect? Here you want to make a break. How to join? Here you want to make a fusion. You want to make a fusion through this. Fusion. So like here, you want to take here. You apply the fusion. Fusion process. When you are making the optical fiber in the form of the straight line, these two ends are perfectly butted together. That is called butted. B-U-T-T-E-D. Butted together. Butted together. Then only these two fiber ends are joined. Here you see here the optical fiber is here is given. This is the one end of the fiber. This is the another end of the fiber given here. In between the broken area is available on which the laser fusion source is available. Once you make everything in a Pakka manner, these two ends are aligned together. Now we want to apply the laser source over which the fusion takes place. Once the optical fibers are fused together, the fibers are aligned together. Okay, the fusions are doing with the help of the automatic splicing equipment. The automatic splicing equipment here is available. Using that, this white region fiber, the both sides are aligned together, in which the computer monitor is available with the display for knowing the various level of functioning process through which the result is being verified and it is being controlled with the help of a microprocessor system available. So this is available nowadays in the Department of Telecommunication System, where they are using this equipment for making the work in a successful manner. So this way there are different methods, fusion methods and mechanical methods, fusion technique and V screw technique, splice method, like this many methods are there. Connectors. Now we want to see the connector. Connector is to be called a temporary connector. Temporary connector. This is to be called a temporary. What are the connectors are available? Generally, connector are a mechanical device that provides a demountable connection between two fibers or a fiber and a source or detector. Here is available ST connector, SC connector, PC and also FTDI. FTDI. This is Fiber Data Distributed Interface. Fiber Data Distributed Interface. Data Distributed Interface. This is nowadays widely used in computer Ethernet. Ethernet application while available, this is used for making 100 megabits per second. Megabit per second data rate. Data rate transmission. Data rate possible. So like this, the different kinds of applications, the connectors are being used in the particular application. Now we want to see the power law budget. What is the meaning of power budget? Nothing but loss budget. The range of optical loss over which the fiber optic link will operate and meet all specifications. The loss is related to the transmitter output power and affects the required receiver output. Then wavelength division multiplexing, WDM. WDM. Wavelength division multiplexing. Wavelength division multiplexing. So in this way, we see the concept of the wavelength division multiplexing. Here we have a different transmitters, namely lambda 1, lambda 2 and so on. At the receiver side, we are having receivers lambda 1, lambda 2, lambda 3 and so on. So like this many things are there available. We look at carefully the signal transmission over the optical fiber. The WDM concept is we have a number of wavelength sources at the receiving end. They generally multiplex and demux. We know the concept of multiplex and demux. Multiplex general mux is said to be called mux. Multiplex and demux. Demux. Mux multiplexer, demultiplexer. This is many to one. Many to one. This is one to many. That is the concept of multiplexer as well as the demultiplexer. So here you want to see this kind of this one. So multiplexer is many to one, demux one to many. What is the meaning of this? Here you want to see the transmitter side, we have a different source. The optical fiber we can send any number of wavelength with that kind of capable available in the optical fiber is going to take all kinds of wavelength through the fibers. So lambda 1, lambda 2 as a source we are having. So these sources are being coupled into the optical fiber is being connected to the WDM device where mux is provided, multiplexer. The nature of multiplexer is to collect many wavelength into a single form which is going to combine all those things and finally collect it and which is being provided through the optical fiber in the form of lambda 1, lambda 2. Then the signal is reached at the output end, that is called a demux, where the demux is going to separate all the wavelength combined together into various level like lambda 1, lambda 2. So like this, these kind of systems available nowadays in communication system. So this is good example for bi-way communication system. Now another important applications of the advanced optical communication system is soliton. Soliton is nothing but a small wavelet. Wavelet is nothing but a pulse propagation without change of optical magnitude as well as the loss energy for any long wavelength region. So this is the advanced research work carried out in optical fiber communication nowadays, through which we are putting repeater every 100 kilometers instead of every 2 kilometers. Currently, the optical fiber communication system is allowed to put only 2 kilometers. Based on the soliton communication system, the fiber optic loop is having repeater at every 100 kilometers. So like this, we want to focus our research in future in soliton fiber communication system. So with the conclusions of this, I would like to conclude the optical fiber communication system in which I covered the overview, the principle,